Most people think the next EV revolution will come from a better battery, smarter software, or a faster motor. But Xiaomi is betting on something deeper: the metal itself. For decades, aluminum helped automakers make cars lighter, stronger, and more efficient. But China's newest manufacturing breakthrough is starting to challenge even that, not with one new part, but with a new way to build the entire chassis. AI-designed metal, giant HyperCasting machines, structural batteries, software that connects the vehicle before the first piece is even made. This is not another Chinese EV chasing Tesla. It is a direct challenge to the way cars have been manufactured for the last 100 years. Fewer parts, stronger structures, faster factories, and maybe the beginning of a completely different auto industry. Before we go deeper, hit like and subscribe if you want more breakdowns on electric vehicles, battery technology, advanced manufacturing, and the companies quietly reshaping the global auto market. Watch until the end, because Xiaomi's real breakthrough is not just the vehicle. It is the warning behind it. Xiaomi's big bet on cars. To understand why this story matters, we have to go back to 2021. That was the year Xiaomi, a company most people knew for smartphones, smart TVs, air purifiers, and home gadgets, announced it was entering the electric vehicle industry. At the time, the reaction from traditional automakers was predictable: skepticism. Because building a smartphone is one thing, building a car is an entirely different game. A car is not just a product. It is a machine people trust with their lives, built to survive rough roads, brutal weather, crashes, vibration, regulations, and years of daily use while still feeling safe and reliable every time someone gets behind the wheel. That is why the legacy automakers of Detroit, Stuttgart, and Nagoya had every reason to doubt Xiaomi. Detroit knew how to build at scale. Stuttgart had spent generations perfecting precision. Nagoya had turned reliability into an industrial standard. And all of them understood the same hard truth: the car business does not forgive mistakes easily. But Xiaomi did not enter like a typical startup. It came with money, software talent, a massive consumer ecosystem, and a founder who understood where the industry was heading. In the electric vehicle era, a car is no longer just a mechanical object. It is connected hardware. It is software on wheels. Increasingly, it is a platform. That is where Lei Jun becomes central to the story. During the launch and testing phase, he did something most chief executives would never do. He put himself inside the product, literally. Lei Jun live-streamed a long-distance endurance test in the Xiaomi SU7 Pro, driving from Beijing to Shanghai while viewers followed in real time. It was a roughly 1,300-kilometer road test, lasting around 15 hours, with the car exposed to highways, traffic, battery pressure, range anxiety, and public scrutiny. The point was not just to prove that the SU7 Pro could travel far, it was to prove trust. No polished commercial, no controlled studio, just the CEO, the car, the road, and thousands of people watching to see whether Xiaomi's first EV could actually deliver. That visibility mattered because Xiaomi was not simply selling a car. It was asking consumers to believe that a company from outside the traditional auto world could build something serious, safe, and advanced. In 2021, the question was simple: can a phone company really build a car? By 2026, the question was no longer whether Xiaomi could build a car. It was whether the old auto industry was ready for a company that wanted to rebuild the car from the metal up. The AI that created Titan's metal. The most important part of Xiaomi's manufacturing story does not begin with a battery, a motor, or a screen. It begins with the metal. For decades, aluminum was one of the auto industry's favorite answers to a difficult problem. How do you make cars lighter without making them weaker? Compared with steel, aluminum reduced weight while still giving engineers enough strength for major structural parts. But aluminum has always come with a compromise. After casting, many aluminum components still need heat treatment. The part is formed, then baked in industrial ovens to strengthen its internal structure. It works, but heat can also make large cast parts warp by tiny amounts. And in automotive manufacturing, tiny amounts matter. A slight change in shape can affect panel alignment, door sealing, cabin noise, safety performance, and long-term durability. So Xiaomi asked a different question. Instead of making the oven better, what if the metal did not need the oven at all? That is where artificial intelligence enters the story. Xiaomi developed Material Genome, an AI-driven platform designed to search for new alloy formulas at a speed no human research team could match. Instead of relying only on trial and error, it simulated millions of combinations, studying how different elements behave when melted, cooled, stressed, and cast. According to Xiaomi's manufacturing story, the AI evaluated more than 10 million possible alloy combinations. A human team testing them one by one would need thousands of years. The AI compressed that search into a much shorter window. The result was Titan's metal, a patented alloy designed to come out of the casting process already strong, stable, and precise, without depending on traditional heat treatment in the same way. That is the key breakthrough. Xiaomi was not simply making a better car part. It was using computing power to redesign the material itself, and that changes the meaning of automotive advantage. For most of the last century, car makers competed through mechanical expertise. Better engines, better welding, better assembly lines, better suppliers. Xiaomi's approach points to a different future, one where the strongest algorithm may matter as much as the longest history. That is why Titan's metal matters. It is not just a new alloy. It is a sign that the car's foundation is becoming software-defined, shaped not only by factories and engineers, but by data, simulation, artificial intelligence, and advanced materials science. The 9,100-ton HyperCasting revolution. Titan's metal was only powerful if Xiaomi could turn it into something bigger than a material. It had to become structure. And that is where the 9,100-ton HyperCasting machine changes the story. This is not just another factory press. It is a massive industrial system designed to inject molten Titan's metal into a huge mold under extreme pressure, creating one of the most important parts of the Xiaomi SU7, the rear floor assembly. In a traditional car factory, that section is not born as one piece. It is assembled from dozens of stamped components, each one positioned, welded, checked, and reinforced. The process works, but it carries a hidden cost: more weight, more time, more complexity, and more places where problems can begin. Xiaomi took the opposite approach. Instead of building the rear floor from 72 separate pieces, its HyperCasting system forms it as one single die-cast structure, one piece replacing 72. And in the process, Xiaomi removes around 840 weld points. That matters because every weld is a possible future weakness, a place where vibration, moisture, cracks, or noise can begin after years on the road. For the factory, the advantage is speed. A part that once required multiple production steps can now be formed in roughly 100 seconds. For the car, the advantage is strength. The integrated rear floor becomes lighter, cleaner, and more rigid. Xiaomi says the part is about 17% lighter than a traditional multi-piece design, while road noise drops by around 2 decibels, the kind of detail that helps a cabin feel tighter, quieter, and more premium. This is why HyperCasting matters. It is not just a faster way to make a component. It is a different way to build the entire chassis and rethink the economics of EV production. The old method created strength by joining parts together. Xiaomi is creating strength by removing the joints. If this breakdown is useful, hit like and subscribe, because this is where the story moves from one factory machine to the bigger question of how electric cars may be designed, priced, and produced in the next decade. The 9,100-ton machine does not just shape metal. It removes complexity from the car itself, the battery that became the backbone. Xiaomi did not stop with the metal, because in an electric car, the heaviest part is not the chassis, it is the battery. For years, most EVs treated the battery like a giant box of energy. It sat under the floor, heavy and expensive, doing one main job: storing electricity. The rest of the vehicle had to carry it, protect it, and build around it. Xiaomi looked at that problem differently. What if the battery was not just something the car carried? What if it became part of the car itself? That idea is called cell-to-body technology. Instead of placing the battery pack underneath the vehicle as a separate component, Xiaomi integrates it directly into the structure. The battery does not simply power the car, it helps support it. It becomes part of the floor, part of the frame, and part of the vehicle's strength. That changes the entire architecture. A normal battery pack adds weight and takes up space. But when the pack becomes structural, the vehicle can be thinner, lower, and more rigid. The center of gravity drops, helping the car feel more stable at high speed and through sharp corners. But Xiaomi made one more important change. It flipped the battery cells. In many battery designs, pressure relief valves face upward toward the cabin, so engineers need extra protective layers. Those layers add thickness, weight, and complexity. By turning the cells downward, Xiaomi directs potential pressure away from the cabin and toward the road. That improves battery safety while allowing the entire battery floor structure to become much thinner. The result is not just a battery pack. It is a structural foundation. It stores energy, protects the cabin, lowers the car, and strengthens the body at the same time. This is the larger pattern behind Xiaomi's engineering. Every major part is being asked to do more than one job. The metal is not just metal. The chassis is not just a frame. And now, the battery is no longer dead weight under the floor. It has become the backbone of the car, a chassis stiffer than a Bugatti. This is where Xiaomi's entire strategy starts to come together. Titan's metal gives the car a stronger material. HyperCasting turns that material into fewer, larger body sections. And the structural battery stops being dead weight under the floor and becomes part of the vehicle's frame. Put those ideas together, and you get something most people would not expect from a company that only entered the EV industry a few years ago. A chassis with extreme stiffness. That may sound boring, but it changes how a car feels. When a vehicle body twists too much, the suspension has to fight the chassis before it can control the road. Steering feels less precise, tires stay less planted, and over time, the cabin can develop squeaks and rattles. A stiff chassis does the opposite. It gives the suspension a stronger foundation, helps the tires stay connected to the road, and makes the cabin feel quieter, sharper, and more solid after years of use. That is why Xiaomi's numbers are so striking. The SU7's body is claimed to reach more than 37,000 foot-pounds per degree of torsional stiffness, a figure that puts it above many high-performance vehicles, and even beyond the Bugatti Chiron. That comparison matters because Bugatti is not an ordinary benchmark. It represents extreme engineering, extreme cost, and extreme performance. Xiaomi is trying to bring that kind of structural thinking into a mass-produced electric car. And this is the real point. The strength does not come from one miracle part. It comes from integration, AI-designed metal, one-piece casting, a battery that supports the body, software and manufacturing working from the same blueprint. Instead of adding more parts to make the car stronger, Xiaomi removes complexity and lets the structure do more work. That is why this chassis matters. It is not just stiff. It is a sign that the future of premium EV manufacturing may belong to companies that can make every part stronger by making the whole system simpler. XIAOMI CHASSIS and the market shock. Engineering only matters if the market believes in it, and this is where Xiaomi's story stops being theoretical. When Xiaomi opened sales for the YU7, its new 5-seat electric SUV, the response was immediate. According to reports, the company received around 200,000 orders in just 3 minutes, and roughly 289,000 within the first hour. That is not normal demand. That is a shockwave. The YU7 was not entering some empty market either. It was aimed directly at one of the most important electric vehicles in the world, the Tesla Model Y. For years, the Model Y has been the benchmark. It proved that an electric SUV could be fast, practical, software-driven, and desirable at global scale. And then Xiaomi arrived with a different argument. Not just lower pricing, not just a bigger screen, not just another long-range battery, a different manufacturing story. The YU7 started at around 253,500 yuan, roughly $35,000, undercutting the Model Y in China. But the real message was not only about price, it was about value, a vehicle backed by AI-designed materials, HyperCasting, a structural battery system, advanced software, premium engineering, and Xiaomi's enormous consumer ecosystem. That combination is what makes the YU7 dangerous. If buyers believe a technology company can offer premium EV engineering, strong performance, battery safety, and aggressive pricing in one package, legacy advantage starts to weaken. Brand history still matters, but it no longer protects anyone by itself. For Tesla, the YU7 is not just another rival. It is a sign that Chinese EV competition is moving from imitation to pressure. Pressure on price, pressure on technology, pressure on speed, and pressure on how fast a company can turn engineering into consumer demand. And for the global EV market, that first hour of orders said something very clearly. Xiaomi is no longer just experimenting with cars. It has become a serious player. The question now is not whether people will pay attention, they already are. What this means for the future of cars. And this is where the story becomes bigger than Xiaomi. Because once a company can use AI to design the metal, use HyperCasting to remove hundreds of welds, and turn the battery into part of the vehicle's structure, it is no longer just improving an electric car. It is changing the logic of how cars are made. For more than a century, the auto industry was built around complexity. Thousands of parts, long supply chains, stamping, welding, bolting, painting, testing, and endless layers of assembly. That system created the modern car and gave legacy automakers a huge advantage. But the EV era is beginning to reward a different kind of thinking. The advantage is no longer just in adding parts, reinforcement, or more complicated assembly lines. It is in designing the whole vehicle as one connected system from the beginning, where the material, chassis, battery, software, and factory process support each other. That is what Xiaomi's chassis technology really represents. Titan's metal is not just a stronger alloy. HyperCasting is not just a faster production method. The structural battery is not just a thinner pack under the floor. Together, they point toward a new manufacturing model where every major component is designed to do more than one job. And that should make the old automotive world uncomfortable. History used to be protection. Legacy brands had factories, suppliers, engineering experience, and trust built over generations. But now, a different advantage is emerging. Speed, software, data, materials, science, automotive investment, and the ability to integrate everything faster than competitors can react. That does not mean Xiaomi has already won. It does not mean aluminum disappears tomorrow. And it does not mean traditional automakers are finished. But it does mean the old playbook is under pressure. The next generation of cars may not be defined only by range, horsepower, or screen size. It may be defined by how intelligently the entire vehicle is designed before production even begins. That is the warning inside Xiaomi's breakthrough. The future of cars may not belong to the company that builds the most complicated machine. It may belong to the company that makes the complicated machine simpler. So when we say the end of aluminum, we are not saying aluminum disappears overnight. We are saying the old way of thinking about car materials may be changing. Xiaomi's breakthrough is not just about one new EV. It is about AI-designed metals, HyperCasting, structural batteries, battery safety, premium EV engineering, and factories where software and heavy industry become one system. For traditional automakers, that is a warning. The future is not waiting for them to move at the old speed. For consumers, it could mean stronger, smarter, safer, and more affordable cars. And for the global auto industry, the next big advantage may not come from the oldest brand, but from the company that integrates technology fastest. Now I want to know what you think. Tesla or Xiaomi? Drop your thoughts below. And if you want more deep dives into electric vehicles, advanced manufacturing, battery technology, and the companies changing the future of transportation, like, subscribe, and turn on notifications. Thanks for watching, and I'll see you in the next video.